And we're live. Good morning. Good morning, world. You know the drill. We don't have much time. The deadline is at 9 a.m., so 50 minutes. Mm, let's see how much coffee is ready. Frappe, classic. Let's see how much of today's Advent code we're going to manage. So it's a die game. I read a little bit before. There's not much to do as you slowly descend to the bottom of the ocean. The submarine computer challenges you to a game of Dirac dice. Let's just get an idea of what that is. Dirac dice. Ooh, is French. Jacques. No, that's Jacques Chirac or something like that. We want. Oh, what is that? Visual Studio Code. Ah, somebody already posted it on YouTube. Wow. Um, okay, it doesn't. Maybe to Google can search for it better than DuckDuckGo. No. Okay, Dirac dice is so maybe it's based off of this scientist. What's his name? Paul Dirac. Okay. So okay, so maybe it's some special something from physics that I'm missing. Let's look at it later. So Dirac dice is a reference apparently to some scientific scientific discovery or something from someone probably named Dirac, and I guess it has to do with some combining. Okay. Anyway, it's probably some wonky, some interesting thing we can dive into the that path some other time. This consists of a die and two pawns. What are pawns? Dice. Okay, good. What are the pawns? Okay, yeah. Of course, the pawns are pieces. Yes. And a game board with circular track containing 10 marked spaces. Oh, don't breathe your coffee. Not smart. So I'm just gonna quickly sketch that out for me here. I have a pen here. So we have a circular board with 10 of these things, one die, and two pawns. Okay. A game board it goes from 1 to 10. 1, 2, 3, all the way 4, 5, 6, 7, 8, 9, 10. Perfect. Each player's starting space is chosen randomly. Okay, that's our puzzle input. Is that all? Okay, that's pretty simple. And then, so everyone starts in a random position, and player 1 goes first. So 1 and 2, B1 starts. Perfect. So players take turn moving. On each player's turn, the player rolls the die 3 times. So I'll just do times 3 for the die, basically. On each player's turn, the player rolls the die 3 times and adds up the result. Then the player moves their pawn that many times forward around the track. That is moving closer. Yeah, okay, clockwise. Yes. So if player is on space 7 and they roll 2, 2, and 1, this is 5. They would move forward 5 times. Okay, yeah. Is that 5? Okay, yeah, because it's 5 moves. 4 plus 4 spaces. And finally stopping on 2. Or? Oh, yeah, okay. Wow. Good morning. Right. So now we have mostly everything we need, I guess. After each player's after each player moves, they increase their score by the value of the space their pawn stopped on. So okay, so E1, E2 score goes. They increase their score by the value of the space they stopped on. Okay, it's always plus final location. It's the current score plus the final location score points every time. Let's see. Player score starts at 0, 0. So if the first player starts on on space 7 and rolls level 5, they would stop on space 2. Yeah, true. Space 2 and add 2 to their score. No, wait, what? They increase the score by the value of the space their pawn stopped on. So if they start at 7 and rolls 5, yeah, sorry, they had brain damage. Never mind. Welcome to the stream. Yeah, so when the players roll, they whatever they stop on, that's their score basically. So for a total score of 2, blah, blah, the game immediately ends when somebody reaches at least 1,000. So winner is 1,000 score. Perfect. Since the first game started, since the first game is a practice game, the submarine opens a compartment labeled deterministic dice. Yeah, so that was pretty cool. So this die, basically, every time you roll it, is not random. It starts from 1 to, and every time you roll it, just increases its value from the previous value. And when it reaches 100, so we have that special case now. I think it's just because they're making puzzle 1 easy. It's the deterministic die. It rolls 1, 2, 3 sequentially, blah blah, all the way to 100, and then loops around. For example, given these positions, so these are the example states that we started. I think I have a good idea of, I hope, of what this does. But if player 1 starts at 4, then okay, but that is interesting to know, to notice. So they share, the die is shared, which means that I roll first and I get 1 to 3, and you roll after and you get 4, 5, 6. So after many turns, blah blah blah, it reaches that score. Since player 1 has at least 1,000 points, player 1 wins and the game ends. At this point, the losing player had 745 points, and the die had been rolled a total of 993 times. All right. So what is the question here? When the practice game, when the player practice game using deterministic counterside die, the moment either player wins, what you get if you multiply the score of the losing player by the number of times the die was rolled during the game. Okay, they usually have like must be some predictable number, because I think that's how the input works in this kind of puzzles. Is always like we just need to return an integer here, so they probably have a deterministic way to always tell what's the correct number given any input. What do you get if you multiply the score of the losing player? So the answer is the score losing player. By the number times number of die rolls. It's during the game. Yeah, it sounds like this should be possible to predict beforehand. But maybe we can try to simulate this. So I'll take this. I think that's the only thing we need from here. And let's make a new. Let's see, what have I changed here? Anything? Okay. Yeah. Okay. We can. Yeah, maybe we can send this up to. Let's see. Oh, to GitHub, but it's yeah. Okay, let's quickly fix that. What's the time? Oh, okay, not so much time. Come on, we can do this. Good morning. Right. So we want to add solutions. This, yes, and I'll just do brain dump here, or not brain dump, but improve a bit. Yeah, I think I remember from yesterday I was about to add some more type hints, but yeah, let's push it as well. But yeah, I ended up doing a stream on contributing to this Visual Studio Code extension because they didn't have a plugin I needed, or like a template I needed. So let's go back to the main branch and just make sure that we have the latest version of everything. I always make sure you do that. And now let's make a new branch from here. Let's name it day 21. But it's fine. I usually name them. I see. I didn't put a dash there, but that's okay. It's not a problem. So let's create in here new file day 21 I, and B, and let's do day 21 Dirac dice. And I'm just gonna give the link here for now. Let's fix this. Perfect. Yeah, so this has to become markdown. And now let's start with we will need the numpy, of course, and we will need the submarine kernel. Did it run? It didn't run, right? Yeah, submarine. Right. So so let's first define our die. So our die is going to be an a linear space from 1 to 100. Yeah, sorry, by step 1. No, what is? Wait. Number of steps. Yeah, okay. Do you want number of steps? Maybe, yeah. Let's do. Is there D type here? There is D type. Perfect. So let's do number of steps. 100, and D type integer. So perfect. So we want to go from 1 to 100 by 1, and we want the most to be integer. So this is now our die. And what I will want to do is, I think we found out the other day how to how to shift the die around. Let's see. Or like an array in Python, which was not the most neat way to do it. But so we can use a combination of pop and insert, or a pop and append. So what we want to do is append. Yeah, so we will do append and pop. So pop the first element. So basically now what will happen is, oh, I wonder if we can do this in NumPy arrays. Maybe not. No, yeah. Okay, but then it's fine. We can make this into a list. Or maybe we can just shift NumPy arrays. Wait. Is there shift? No. Swap. Pop. No. Move. Shift. No. Wait. No. Pop. No. Move. No. Lag? No. Strange that they don't have it. Maybe it's called something else. Item size, mean, number of bytes, the new byte order. Real, repeat, resize, search, set, squeeze, strides, swap, axis, trace, transpose, var view. Oh, that's annoying. They really don't have that. Anyway, we have a solution. We are not gonna like optimize now. Perfect. So let's make this a list. So then we can do this. And we need to print it so that we can see what's going on. Print die. So every time I do it, you see it moves from the first position to the last position. So basically what I wanted to create is to shuffle, to like every time we roll the die, we never like actually lose the so this is the deterministic die. Let's name it as such. Actually, deterministic die, and we rename this as well. And then this I'm gonna make into a function just so that it's easier to call. Roll die, and I'm gonna die is here, and it should be list, and it returns a list, which is basically itself. Right, so what we want to do is we can rename these into die. We can take this away, and we can return the die. So what we will want to return actually is the first three. So if we roll it once, we know we're gonna get the three items. So let's see. Right, so what we can do is number. I can say here times. It's an integer, and by default it's going to be 3 because we know it should be 3 for for like a roll in times, in range times. So we roll it as many times as we need. We will get we flip it once, and then we need a out rolls here, and what we'll do is rolls append die 0. So we keep the first value, and then we return the rolls once this is done. So right, so now if I take this way, so if let's see what's the time. Okay, half an hour left. So roll die should if we do the deterministic die should be perfect. It returns all at once. Let's see, will it roll around, like circle around? Yes, perfect. Did it do it strangely, or was it? Let's see again. 96, 99, 100, 1, 2, 3, 4, 5. Okay, perfect. Yeah. Perfect. So we need to initialize our die again. I'm gonna initialize die Dirac the deterministic die here down, and we don't want to roll yet. We can keep this for ourselves. Perfect. So we have that. So we have the die, and we need the two pawns. Player one. Maybe let's keep it simple. Oh, and it will be actually. Let's do it the same way, so it's easy. I see a pattern here. We could make this into. We could refactor this into the same nice function. So initialize players. So let's create the player or like a board. Sorry, board. So let's create the board here, which is going to be again a linear space. Yeah, I realize now I don't really need to use numpy here. Actually, I can just do it like this directly. I for or like yeah, space or position for position in range 1 to 100. But I think this is going to, let's see, I think this is going to stop at 99. Yes, exactly. So we want this to be 101. Perfect. But actually, we don't want it 101. We wanted 11. The positions are 1 to 10 on the board. Yes, correct. So I'm not going to change the other one up there. It's fine. Positions is 10. So I'm just going to make this here nice. Positions in case we need to do that in the future. So we have the board. Just to print the board is ready. And I can do board here. And let's just print this and just create a board player. Yeah, so what I'm gonna do is I'm gonna create a board, or I'm gonna keep track of a board for each player. So instead of creating one board, I'm gonna create two for now. To initialize players, let's just keep track of the players' positions instead. There's 10 possible positions, and instead of board, let's say the player one. The player one was board position is ready. So board positions are ready. And then let's do the same for player two. So 1, 2 here. Let's name it like this. The player 2 board positions are ready. And now we just need similar board move. So we need the board input, which is a list, and it's going to be the player position basically. We need the rolls, the die roll actually, die roll. We would like the total in an integer format, and then what we will do is for roll in roll a die roll. I don't like that these overlap on top of each other. Then for each which of those, we do the same thing. We take the board and we append the current position at the end. So this way, and we don't need to, let's see. Yeah, because we affect, and I think this will have a side effect to the board. Yeah, exactly. So actually we don't, we can leave this like that. So this board move will affect the player's position directly. So if I do, let's say player 1 is moving, let's say he rolled 5 and he's moving 5 times. If I print his position, player 1, we'll see it's circling around, right? Because it's moving 5 to position number 5. Now, so he's on position number 1. Let's see if we did this right. So if I'm on 1 and I roll 5, then I go 1, 2, 3, 4, 5. So we did it wrong. So it should be +1 here because we don't count the current position. So let's see. Right. Then it. So if we roll 5, we go to position number 6, since we are already at position number 1. And what we do then is, yeah, we add. So actually, how I'm gonna do this is, right, yeah, we're gonna roll. I have an idea. To start each player, we're gonna roll a random die. So let's comment this one out. We don't want this. So from NumPy, let's take random int. So we can get a random integer, and we want it to be an integer from 1 to 100. But are these included? Can we roll 1? Okay, maybe that's not the way to find out. That's the way to find out. NumPy random branding. Let's see. Inclusive. The high is exclusive. Okay. And the type, we want it to be an integer. Int, and the high is exclusive. So I'm gonna do +1 here. Actually, we already have this determined. No, we don't, but we can say here dimensions is 100. I always make this mistake with S and T in English. They both kind of sound similar to me sometimes in dimensions. And what's the difference between dimensions with a T and dimensions with a S? Oh, sorry. I don't know. So let's keep this going. And 22 minutes. So we have the board move, and we come here and we place this as well. So now this is inclusive to right. So we get so this is a half open interval. If high is none, then it goes from 0 to low. Okay, if it's negative, maybe then. Let's see. Random integers. Yeah, perfect. So now we have our, this is basically a random initialization. So let's initialize the players on the board. Let's do this here. Initialize player location. So do we have an instruction on that? Should it be, should they roll a couple of times, or doesn't matter? The starting space. No. Okay, sorry. I forgot about that. It's not random at all, actually. It's given. So we actually don't need this. So I'm gonna do example input here so that we can have the same thing. For now, I'm not gonna parse the string input. I'm gonna just place this here and just say, so assume that the first position is player 1, the second position is player 2. So we have 4 and 8. Yeah, and we can player do it like this. Player, wow. Print. So yes, perfect. And we can maybe do this. Yeah, doesn't matter. So now that we know where they start, we have to align the board in that position. So actually, since they are both initialized at position 1, it's pretty easy. We can just go here and take board move for the player 1 and do example input 0 plus 1. Sorry, minus 1. And the same for player 2. And it's minus 1 because it's what we corrected for before, is that we don't count the current position when we actually roll and we're about to move. But in this case, we need to arrive at position number 4 because we know we are initialized at position 1. We just need to go ahead 3 steps instead of 4. So if we do this, I'm just gonna print initial position for player 1 is player 1 0. So this is the first. Yes, perfect. And then here it's the same but player 2. And if we run this only once, it should be correct. No, it wasn't. Did I mess something up? Let's run everything. 5 and okay. Example input minus 1. So it did 3. It went from 1. Wait. So four steps ahead from. What am I doing here wrong? So we're at 1 and we 4. It is, yeah. So it is minus 2. Sorry. I got this wrong indeed. So let's run this again. And perfect. Yes, we are at the correct spot. So finally now we actually need to start playing. And since we all have our fake random starting positions, and actually we are going to repeat this until someone. We need to also calculate the score. So let's create a score calculation. Let's see. We can keep track of the score. It's fine now. Let's do it score separately. It's just 2 players. And then the puzzle 2 is going to be, what if you are playing with like the entire universe and you need to play with 1,000 players? Then I'm gonna be like, okay. 15 minutes left. Score P1. Let's initialize it to 0. And score P2. Initialize it to 0. Actually, I can rename this section here as let's play, because now we have initialized our scores, and we need to while score P1 is less than 1,000 or score P2 is less than 1,000. We want to be looping. right? We want to be looping until somebody goes over. And what we do is at each point we roll. So we start by rolling. So let's say player 1 starts. So roll die deterministic die 3 times. So we don't need to specify this. Or like die rolls is 3, so we can, why not? We can put this here, die rolls. So now we know the position from the deterministic die is the first. Sorry, roll. What does it do? I forgot already. Oh yeah, we get the 3 rolls, right? So now it would be nice actually if we return instead a numpy array and the array. So let's do that instead. np array rolls. Because now it's simple. Now we can do this. So we always know the total. Not total, but rolls here. Now we know the total. Yes, correct. And so now that we know this, we go in board move for layer 1, and we say actually rolls sum. And I can remove that from here, and then we do the same for and then once that's done, then the score of layer 1, it becomes itself plus the current position, which is this. And let's do the same for player 2. Layer 2 start plays, and it's, yeah, you can tell already that this is relatively simple to verify. There's a lot of factoring that we can do. So what we want to keep track of is the score of the losing player and the number of die rolls. So num of or like count of die rolls is 0, and every time we roll the die, we do count of die rolls plus 1, and 1 here as well. And let's run this. Oof, that takes a while. So the score should be print. Oof, I feel like it's a very inefficient thing I've done here. And let's see, score, 12 minutes left. The answer is, oh wait, of course I also made a mistake here. This should be, which should actually make it faster. Oh my god, that's going to be horrible. It should make wait, so what I'm gonna do is, just for the sake of visualization, let's see if the score of player 1 or is a multiple of 10. Say, is 12 a multiple of 10? No, right? So just testing here. So, but there is a problem. 100 is, 101 is not perfect. Yeah, so it's going to be a bit too many maybe to print. So let's take by 100 print player one score is P1. Score P1. So actually, I'm gonna do this if either score changes. Or like evaluates too. So we want to not. We want the opposite of this, and or let's see, or the opposite of the score of P. So every time there's either of their scores is divisible by 100, we wish to see that player one score is score P1, and let's make this 4 digits, and the same for player 2 score, just because I feel like I messed something up. Let's see. Oh, it's over. Okay, that was fast. Right, so I did mess something up. Let's see. The answer is the score of the winning player. So, no, sorry, the score of the player that lost. Wait, what? But so this player 2 won first, but it did not stop. Did I mess something up, or is this? Oh yeah, of course, classic. This should be and. Yeah, exactly. So now, it's missing a last. Yeah, of course, it's missing the last one, because it's not a multiple of probably of. Okay, 8 minutes, but we got this. So the answer is whatever player. So player one lost, so it's his score. Let's see. Right, so we can say here. Winner is. Never mind. We don't need to do this programmatically right now. Let's just show and print. The die was rolled. Count of die rolls times. So we can calculate the score. It's this one times this one. So let's see. The answer is yeah, why not? This one times this one. And if I put this in, it will hopefully give us our first star of the day. No, no, of course not, because I'm using the example. So what was the? Oh no, something is wrong. Yes, something is wrong, because actually every time here is die rolls like this and die rolls like this. So we're not just adding one roll every time, we're adding 3. So let's run this again. That was rolled 1128 times. That is also incorrect. Damn it. Yes. No. Kind of die rolls. But why is it incorrect? Wait, but did we get the losing player had 4 and 8? Something strange is happening actually, because in their case, the player reaches 1,000 right away. In our case, Score is 1001. And the player is... And we have player 2 winning. Oh, wow. Okay, 5 minutes left. Oh, I did mess up something. Oh, yes. I know I did messed up, of course. Like, I'm running this. So now it should be correct. I have to run this always. No, that's also wrong. Let's see. 4 and 8. 4 and 8. Their score is 0. I have to run everything all the time, of course, because some things in here, you can't run them independently. The rolls are 3 rolls. Okay, I've messed something up. Sadly. The player 1 should win. Which, I mean, it makes sense, given that the player 1 starts first. Right, we just add and move space 10 for the score of 10. Right, let's evaluate that. Let's break at the first one and just show the scores. 8 and 9. Okay, that is wrong. Yeah, it is wrong because I have to run everything. Yeah, 4 and 7. Board move. So did I mess something up on the board move here? Let's see. The board move happens. Huh. Is that not supposed to? Wait. The player 1 score is 4. Does that mean that the location of player 1 is how does it look like? 4? Yeah. But it should have been, because the player 1 rolls 1, 2, 3. Did I mess something up here? Pasting things? No. Let's see. Rolls is 5, 6, 7. And the sum of that is 18. Okay. Okay, I see what happened. The first time, the roll should not move at all. Special case, if count of die rolls is 0, then we want rolls to be 1, 2, 3. I'll bake it for now. Or actually, yeah, np array. Yeah, because what happened is that, and then we move this into an else 2 minutes. Okay, we got this. And remove that. Please work. Run everything. No. Oh, okay. Do it again. Run everything. 2. Damn it, I know what's wrong. Okay, but we ran out of time. Okay. Well, I have to go back to work, but we almost got it. Damn it. What's wrong is that the first time we roll the die, we're not actually rolling it. It's the first 3. Damn it. So what's wrong here is that when I roll the die, it goes ahead 3 times. So the first time we only needed to go. No, that's correct. So if I roll it, okay, we run out of time. But if I roll it like this, oh, wait, where did the first spot go? Ah, okay, this is what's wrong. No. Okay, okay, give me, please, please. Okay, I'll go a little bit over time, but uh, this should be correct now. Please tell me it's correct. Um, wait, let's remove. Okay, yeah, let's remove this and just try the whole thing again. Okay, 1 minute over time. Yes, yes, that is correct. Yes, exactly. So 753. Seven. No, the score is wrong. No. How can the score be wrong? It was rolled 996 times. Okay, yeah, it wasn't. Okay, I've done some other silly mistake. Anyway, maybe we'll catch up later. We didn't get the swag of finishing the puzzle first this morning, but see you around later. Have a great day, everyone.